Sorry, you guys can hear me now?
Yep. I can hear you and see your screen.
All right, thank you very much. I'll just jump right into it here. Today I'll be talking about liquid chromatography and mass spectrometry strategies for additional metabolite identification. So I'll be talking about 3 projects very quickly and just kind of jump into the first one. So the first one was published in Analytical Chemistry last year, where we looked at just how much we can improve one-dimensional separations. And so we looked at conditions that aren't necessarily used for conventional methodologies, where you're looking at quantifying many things and having good resolution. But in the interest of identifying things with spectral databases, we looked at employing larger masses loaded, longer gradients, and the use of iterative acquisition or rolling precursor ion exclusion to see if we could increase the number of candidates we could match to spectral databases, as well as improve the quality of our unknown data sets. And so you're probably right in thinking that this isn't a great idea for the for chromatography or just the instrument cleanliness. You do lose some chromatographic resolution, but what I hope you see here is the large benefit you also get in the signal that you're seeing from a high loaded sample in red to a lesser loaded sample in black. And so we looked at reverse phase and Hillick, both positive and negative analyses, and comparing a conventional methodology of about 20 minutes and lower sample loading compared to something as long as 3 hours and much higher loading, as well as 8 iterative injections. We are able to match way more candidate spectra to the databases with pretty high confidence. And so we can do better than this too. And that's kind of what the goal has been all along and what we're working on currently, where we're using offline 2-dimensional LC-MS. So these samples are fecal samples that we're playing with from Casey Therio's lab of NC State. And so these are people that have C. diff infection. So we have samples before they get a fecal transplant and after, as antibiotics weren't successful for them. So how we imagine this working and how we've kind of started the methodology or the acquisition of this data is we run these samples in a more conventional approach to figure out the differential features between them. You then pool the samples and use a larger bore column on the first dimension and fractionate. You use a larger bore as you can load more sample than the hundreds of microliters of sample, as well as higher concentration, and not be as affected by overloading. You then can collect those fractions and pre-concentrate them even further and run them just as a simplified matrix on the second dimension of higher signal intensity. And then it's just the process of merging these two together, which don't want to underestimate as a hard challenge in itself. And so this is just kind of give you a glimpse of how this is working for us. So this is a model system of rat fecal matter. And so the fractions on the z-axis from first to elute to last are shown here. And so this isn't a very orthogonal column chemistry. We've been exploring other ones, including Hillick. But as you can see here, here's an unfractionated sample. So this is a pooled sample just run on a 1-dimensional method compared to the 2-dimensional approach that we're talking about here. And you can see a large increase in signal intensity that we're starting to see. So we're really excited by the preliminary results of this stuff and hope to get this published relatively soon. And so we keep track of all of our identifications with a custom-built software called MetID Tracker. It was developed by Dr. Alexander Raskine and is focused for those that are interested in mostly their identifications. And so all of this, this software incorporates, it shows all of your MS-MS features you collect, as well as the candidate spectrum in a visual manner. So we also have things like NIST match score or entropy score that Oliver Fines touched on earlier today, as well as giving some more information about what it is and links to databases to kind of check the biological relevance. And so a beta version is available right now, but version 1 is full release is expected to be available in the end of 2022. So that's the end of my talk. There's many people I've been fortunate to work with, and they have some talks coming up throughout this meeting this week, and I encourage you to attend. So I can answer any questions in the chat. Thanks.
Thank you, Brady. We actually have time for a question or two of Brady, if you'd like to ask a question, or we can go to the chat.